Hello friends, welcome to Secret of Electronics. In this video we will learn how we can control AC 220 volt load through Wi-Fi and manual switch. We will not use any GPIO pin of the MCU for manual switch. This circuit allows you to control an AC load such as bulb both from a web page by the Raspberry Pi Pico W board and manual through a two-way switch, while also providing real-time feedback of the load status without directly using any GPIO pin of the MCU for switch. The Raspberry Pi Pico W drives the relay module through GPIO 0 using a BC547 transistor as a driver with an LED for indication and a flyback diode for relay coil protection. The relay's common NO and NC contacts are connected to the AC load and supply, and a parallel two-way switch is wired so that either the relay or the manual switch can independently turn the load on or off for feedback instead of directly monitoring the switch. An optocoupler PC817 is used. The AC load status is sensed through a bridge rectifier and a smoothing capacitor, which lights the optocoupler's LED when AC flows to the load. The optocoupler output is connected to GPIO 1 of the Raspberry Pi Pico W board through a pull-up resistor, allowing the MCU to detect whether the load is on or off, regardless of whether it was switched by the relay, web page control, or the manual switch. This method provides isolated, real-time feedback of the actual AC load state while keeping the MCU safe from mains voltage. Runs the Pico W as a Wi-Fi access point, serves a small web page that lets a user turn an AC load on or off, and reports the real-world relay or load state using a feedback pin optocoupler. The web page pulls the device every 800 milliseconds so the UI reflects manual switch changes. Network socket time machine.pin are the modules used for Wi-Fi TCP sockets, delays and GPIO control. AP_SSID and AP_pass configure the Pico as a Wi-Fi access point. The password is required to be at least 8 characters. Relay_pin and FB_pin are the two GPIOs used, one output to drive the relay, one input to read the optocoupler feedback. Relay is configured as an output, feedback as input. Relay.value 0 sets the relay off at boot, activates the Pico W's access point interface. ap.config sets SSID and password. The small loop waits up to 5 seconds for the AP to become active. Then ap.ipconfig prints the IP address, netmask, gateway, DNS, set_relay, true false, energizes or de-energizes the relay, get_status_tags reads the feedback pin and returns a string. The HTML string contains the web page served to clients. Key parts: a simple UI with a status batch and two buttons, turn on and turn off. Footer displays the Wi-Fi SSID. Important JavaScript functions: send command /relay/on or /relay/off tells the server to change the relay state. The page pulls /status every 800 milliseconds to reflect the real hardware feedback, enabling synchronous with a manual switch or other physical change. Creates a TCP server listening on port 80 on all interfaces. S.set_timeout 0.5 makes accept non-blocking. It will race on timeout, which lets the main loop to periodic housekeeping rather than block forever on accept. Main server loop, high level flow inside the while true. Try to accept a new client connection. C1 remote equal s.accept. If accept times out, accept OS error triggers continue and the loop restarts. For accepted connection, C1 file equal C1.makefile rwb0. Create a file like object for reading request lines. Read the first request line, get slash path http slash 1.1. Read and discard the rest of the http headers. Routing slash or slash index. Send the full HTML page. Slash relay slash 1. Set underscore relay true. Respond OK. Slash relay slash off. Set underscore relay false. Respond OK. Slash status. Call get underscore status underscore tags and return that tags. Client JS reads and updates UI. Else return 404 not found. Accept sessions. Attempt to return an HTTP 500 then close the client. Finally close file socket for that client. Now connect the Raspberry Pi Pico W board to your PC or laptop. After connecting, open the Thony IDE. Once Thony IDE is open, you can see the Micropython version displayed under the shell. This indicates that the Raspberry Pi Pico W is successfully connected to your PC or laptop. Next, copy the Micropython code, which you can download from the given link in the description, and paste it into Thony IDE. After pasting the code, save the file on the Raspberry Pi Pico W board as a main.py. Now the code is successfully uploaded to the Raspberry Pi Pico W board. Next, disconnect the board from your PC or laptop and connect all the components together according to the main circuit diagram we discussed at the beginning of this tutorial. I have already created a PCB for this project, so I just need to connect the Raspberry Pi Pico W board to this PCB. If you want the PCB layout, you can download it from the given link in the description. Now I have connected the Raspberry Pi Pico W board to a 5V DC power source, and I have also connected a 220V LED bulb as a load with a 220V AC power input. As you can see, now open your smartphone's Wi-Fi settings and turn on Wi-Fi. After some time, you will see Pico underscore home underscore auto. Click on it, and when promoted, type the password that we declared in the code. After entering the password, click OK. Then open your smartphone's browser, type the IP address of the Raspberry Pi Pico W board and press enter. As you can see, we can turn the load on and off through a web page. We can also control the load using a manual switch with real-time feedback. If you liked this video, then do not forget to subscribe to our YouTube channel to watch our upcoming interesting tutorials.